Okay, this question says describe the difference between substitutional alloys and interstitial alloys. And to help illustrate that, we have a metal structure drawing shown here where these little circles represent atoms within a metal structure. Now, for substitutional alloys, what we have are essentially a whole bunch of substitutional defects where one atom substitutes for another. And so there's no rhyme or reason necessarily which particular atoms are substituted, but this could, for example, be brass, where we have copper atoms and zinc atoms. And copper atoms and zinc atoms are about the same size, and so you can argue that the copper atoms are substituting for the zinc atoms, or the zinc atoms are substituting for the copper atoms. But either way, since the atoms are about the same size, they replace each other fairly readily. Okay. Now, for an interstitial alloy, we don't have atoms that are about the same size. They're not about 10% the size, within 10% of the size of each other. Rather, what you have are really small atoms compared to the metal atoms usually of interest. An example of this would be something like steel. So in the case of steel, what we would have is, say, these would be an array of iron atoms in a crystal structure, and the very small carbon atoms would sit in between these larger iron atoms. And what we have here are a bunch of what we call interstitial defects. These carbon atoms would sit in the interstices between these atoms. In both cases, you can have an alloy being harder than just the pure metal, because the differences in sizes in these atoms can essentially roughen the slip plane surfaces, and it makes these metal structures, crystal structures, harder to deform. You can also have alloys that have a mix of interstitial and substitutional defects. And in fact, there's a metal here that I wanted to show you that has so many defects that it doesn't even really have a crystal structure. It has to be cooled very quickly and processed just right to not have that crystal structure. But I want to show you how hard it is by dropping in these two little metal spheres. This is stainless steel. This is stainless steel capped with this special amorphous, that is non-crystalline alloy. And so I'm going to drop these in here, and the harder surface will cause the balls to bounce higher. Okay, so I'll drop these in here, and you can see there's a definite difference in that the alloy with lots of defects in it, no crystal structure, is a much harder alloy.